Relative humidity. The moisture in air is called vapor and is measured as relative humidity. So if the relative humidity of air is measured at 20%, that means the air is holding 20% of the moisture that it is able to hold at its current temperature. To help understand relative humidity, imagine a sponge that is able to hold 1 cup of water. If half a cup of water is poured into the sponge, then the sponge will be holding 50% of the water it is able to hold. If you were to add another 3/4 of a cup, the sponge would only be able to hold 1 cup total, so 1/4 of a cup would drain and the sponge would be holding 1 cup, 100% of the water it is able to hold. Now, when you squeeze the sponge, water will drain because you are reducing the size of the sponge and its ability to hold water. Let's say you squeeze 1/4 cup of water from the sponge. Because the sponge is being squeezed, its capacity is decreased, and the 3/4 of a cup of water left in the sponge is 100% of the water it is able to hold in that squeezed state. When you release the sponge, it will still be holding 3/4 of a cup of water, but in its unsqueezed state, it can hold more water. So that 3/4 of a cup is now 75% of the water it is able to hold. As you can see, the amount of water the sponge is able to hold is relative to how much the sponge is squeezed. Similar to the sponge, air holds molecules of water, and when the air holds 25% of the water molecules it is able to hold, we know it has 25% relative humidity. When the air temperature decreases, the effect is similar to squeezing the sponge. Decreasing air temperature decreases its ability to hold water molecules. And once the air temperature decreases to the point where its relative humidity reaches 100%, that extra vapor has to go somewhere, so condensation starts to form. As you can see, humidity is relative to air temperature. Air barriers. We discussed the importance of air barriers in controlling heat loss, and now that you understand relative humidity, you can see how air barriers also protect the home from water damage. The relative humidity of any interior air that escapes through exterior walls or ceilings will increase as its temperature decreases, and the relative humidity of this escaping air may reach 100%, the dew point, inside the building envelope. As the air continues to move through the building envelope, it may deposit water in the form of condensation, which can cause serious water damage. The amount of water damage from this leaking air depends on a number of factors. The temperature of the exterior air, the relative humidity of the escaping interior air, the temperature of the escaping interior air, and the amount of interior air that is allowed to escape. The temperature of exterior air is uncontrollable, and home buyers control interior temperature and humidity levels. So the only factor home builders can affect is the integrity of the air barrier so that we minimize the amount of interior air that is allowed to escape. Your diligence as an RCSM will ensure water damage will never occur as a result of an inadequate air barrier. Vapor barriers. Much like heat, vapor also moves through materials in a process called vapor diffusion. This type of movement happens at the molecular level, and the rate of vapor diffusion through a material is dependent on the permeability of the material's ability to allow vapor movement through it, the amount of vapor pressure, a force created when there are high and low levels of humidity that are trying to equalize. The greater the difference in humidity, the greater the vapor pressure. In cold weather conditions, there is more vapor in the warm interior air of a home than in the cold exterior air, and as a result, vapor pressure is created. In these conditions, the vapor inside the home will be forced to the exterior until it equalizes and there is no more vapor pressure. And because we understand relative humidity, we know that this movement, combined with the decrease in temperature, will result in condensation inside the building envelope. In order to minimize the potential for water damage in the building envelope, we must install a vapor barrier on the warm side of the insulation to counteract the forces of vapor pressure. The building code defines a vapor barrier as material with a permeance less than 60 nanograms per second per square meter per Pascal. Since the lower the permeance, the lower the rate of vapor diffusion. The amount of vapor diffusion through a building envelope depends on a number of factors: the external level of humidity, the internal level of humidity, the permeance rating of the vapor barrier, and the continuity of the vapor barrier. However, note that a vapor barrier can only slow the movement of vapor. It does not prevent all vapor from diffusing through the building envelope. Again, because the external level of humidity cannot be controlled, and the internal level of humidity is controlled by the home buyer, as an RCSM, it is your responsibility to verify that the permeance of the specified vapor barrier meets the minimum requirements of the building code, and to ensure the continuity of the vapor barrier when it is installed.